All right, so we have to worry about exceptions, right? We don't want to remove from an empty list. That one actually tell exception. So we say we check is empty. Does it need to throw exception? It just say is it empty or not, right? Which is turned to a false, right? No need for that, right? Only the remove, right? And this is unbounded linked list, so when you add, there's no such full, right? This is full exception, we don't need that. So yeah, technically only one here. Now we have to make sure if the list is not empty, then we do. Else, or sometimes people just do it this way. If it is empty, we just throw, right? And call new empty list exception, and the list is empty. And you may see that you just do the rest of implementation. It will never get to this line if it's empty. It's going to throw first. Now let's talk about remove. So we can pretty much technically move your head, right? So I'm talking about our linked list when we add look like this so far. When you remove, just move this arrow pointer to the next one. And this is garbage collection. Jerry clean it up. Don't have to worry. So we removed from the top. This is just like stack. So what we can do is this LL pointer equals to LL pointer dot get pointer, and we just remove. We're gonna have to verify if it works. We may add the unit test again, and contains is pretty much the same, like you iterate through it to see if it's there. But let's talk about remove first. So how to use the unit test again? Go to the class level, right click, L enter, and create test. Right. L enter, create test. Okay. Click on create. Don't go to the other windows. Just click on it. And that's all the tests that we need. So we have to test them all, right? Better to have select all, huh? Where? On the test package. Okay, some of them already have. I already have is empty and add, so I don't want to check that. Right click, no, L enter, create test. So we have is empty and add, so we gotta do the rest. Oops, I didn't have the right package. Let's delete it. I'll enter, create test package. Remove contains, let's get. Yes, update. All right, so we have them here. Oh, because part of the object. So it's yeah, we're gonna remove toString. We don't need to test that. Only the method that you for functions. Now we're gonna test remove right there. So you may do just the same like that, right? Let me, instead of doing, I'm going to copy some of the code here to use and change from add to remove. And make sure that this one is in the beginning, the list, right after the class, which is the attribute of the class. We're going to say we add them, right? Now we're going to remove after add. So this is the place we start to remove. List dot remove. We want to remove alright, so this is going to be an interesting thing right here. The way I remove it as like a stack, like a pop, which I don't care about the elements that you try to remove. Right? But if you talk about list, you have to thought about which item in the list you want to remove. That's why implementation is going to be different. Right? The way I do now, it's just another type of remove, like a pop. That's why I never search into a list and remove it back. And return pretty much just return. It's not done. We have to put temp, right? Equals to ll pointer and dot get elements. So this is going to be e temp and return the temp. Okay, which technically you don't really need to use this for pop, for stack, or for queue, DQ. You don't need to have that as the parameter. Then what I'm going to do, I'm going to just show the remove this way first as an overloaded. Okay. And when I do that, pretty much just remove George. Then we expect to see, so we go to assert, right? Assert George should be away. Is it also space too? When you push, this is just the toString, right? So toString is going to be no space. Okay. So we expect to see Edward David, right? All right, we can test that. So it passed the test. So it works. Okay, I can just, since my remove returns the value that I removed, then I can just say, okay, this is gonna be a person that on their, what do you call, flag, right? So I'm gonna flag that person. Now I can just print the flag to see. Okay, the flag is, right, which is right, because this guy, I suspect it's keep logging in. I suspect that it's gonna be a robot, so remove that, something like that from my application. And I have to name that I remove. The flag is George, right? But if you do void, it's fine, but you don't know what you remove out. It's just all about the list here, right? Which now, since this is list, that's why, since I'm talking about linked list, so I just happen to show you this is can be, if you want to do stack, you should say like linked list stack implements iStack instead, right? Then you get the iStack, which is when you pop, just like remove without the parameters, right? Now, use linked list. So now I want to show you, how about if I want to do an order list? Okay. Now, let's talk about order list. And I actually want to start out with, instead of testing with string, I want to test with user. Because it's very important to order list by the class. The class itself must implement. In order, let's say for example, in order to order something, how will you know that user? How will you order user by first name? Like for example, my linked list now is a user. Right, I'm going to test that, right? And I already have the user class by, if I importing, I have model.user, right? And we'll just say this is user. This is from your assignment 1, right? New. Let's see, what do I have as a constructor? Username, password. Okay. New username and password. And call user. Right, so yeah, let's test this too to see, besides, since we use generics, right? We want to see it work as expected. Oh, it's George. Alright, so that's how we're gonna add. So now this is gonna be a user instead. Okay, and this should call to string version of the user. And this might not be right anymore, right? Because it has to be this two-string version of this. have to go to user